Hello everyone. Question is, you are an ML engineer working for a logistics company that uses multiple machine learning models to optimize delivery routes in real time. Each model needs to process data quickly to provide up to the minute route adjustments. But the company also has strict cost constraints. You need to deploy the models in an environment where performance, cost, and latency are carefully balanced. There may be slight variations in the access frequency of the models. Any excessive cost could impact the project's profitability. Which of the following strategies should you consider to balance the trade-offs between performance, cost, and latency when deploying your model in Amazon SageMaker? Select two options. Option A, choose a lower cost CPU instance accepting longer inference times as the savings on compute cost are more important than minimizing latency. Option B, leverage Amazon SageMaker Neo to compile the model for optimized development on edge devices, reducing latency and cost but with limited scalability for large datasets. Option C, use Amazon SageMaker's multi-model endpoint to deploy multiple models on a single instance, reducing cost by sharing resources. Option D, implement auto-scaling on a fleet of medium-sized instances, allowing the system to adjust resources based on real-time demand, balancing cost and performance dynamically. Option E, deploy the model on a high-performance GPU instance to minimize latency regardless of the highest cost, ensuring real-time route adjustments. Correct answer is option C and option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are a machine learning engineer at an e-commerce company that uses a recommendation model to suggest products to customers. The model was trained on data from the past year, but after being in production for several months, you notice that the model's recommendations are becoming less relevant. You suspect that either data drift or model drift could be causing the decline in performance. To investigate and resolve the issue, you need to understand the difference between these two types of drift and how to monitor them using Amazon SageMaker. Which of the following statements best describes the difference between data drift and model drift and how you would address them using Amazon SageMaker? Option A, data drift occurs when the distribution of the input data changes over time, while model drift happens when the model's underlying assumptions or parameters becomes outdated. To address data drift, you should use SageMaker Model Monitor to track changes in input data distribution. For model drift, you should periodically retrain the model using the latest data. Option B, data drift is a sudden change in the model's accuracy, while model drift is a gradual degradation in model performance. You should use SageMaker features to manage both types of drift by standardizing input data. Option C, data drift occurs when the model's predictions start to deviate from the expected outcomes, while model drift occurs when the model's accuracy declines due to changes in the input data. SageMaker pipelines should be used to automate retraining for both types of drift. Option D. Data drift refers to changes in the model's accuracy due to shifts in the data, while model drift refers to changes in the underlying data features over time. To address both, you should use SageMaker Clarify to detect bias and retrain the model monthly. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.